Clone Alpha isn't just another human-like bot built with bolts and screws. It is groundbreaking AI that can seamlessly replicate biological functions of humans, from the flexibility in our fingers to the distinct gait of a human walking on uneven terrain. The complex ways in which our muscles contract and tendons and joints interact took millions of years for evolution to perfect, and now we have the same power to replicate that in AI. Clone Robotics is working on a project that could change how we view robots and close the gap between humans and machines. These robots have a synthetic organ system capable of mimicking the biological systems and processes of plants and animals. In other words, that's just a fancy way of saying the robot learns by observation from living organisms to become better at its tasks. For Clone Alpha, an AI humanoid bot, that means replicating human movement with startling fluidity that's uncharacteristic of other humanoid robots, including some of the more advanced humanoid robots making waves in the industry, like Tesla's Optimus bot. Unlike the Clone Alpha, the Tesla bot still relies on traditional electric motors, which, while impressive in their imitation of human movement, is still quite clunky and distinctly robot-like. On the other hand, the Clone Alpha is powered by synthetic muscles that mimic human anatomy to a startling degree, with biomimetic systems that allow for more lifelike and fluid movements. As a result, if you were to give the Clone Alpha and Tesla bot the same task, the former would be able to complete these tasks with more precision and dexterity. Of course, it doesn't hurt that the Clone Alpha features an impressive 164 points of articulation in its upper body alone, a clear testament to its advanced design. Beyond having remarkably flexible joints, the Clone Alpha utilizes Myofiber technology that mimics the structure and function of human muscles. So instead of rigid actuators and motors, they use soft, water-powered artificial muscles. As a result, the myofibers contract and relax in a similar fashion to human muscles, which adds greater fluidity and precision to their movements. So it basically makes it look more natural. Also, despite these synthetic muscles being incredibly lightweight, they're surprisingly powerful, with a mere 3 grams of muscle being able to lift 2.2 pounds of load. And by being able to contract to 30% its initial length in a millisecond, the Clone Alpha is able to achieve high levels of performance while minimizing energy consumption. Besides the added power, Clone Alpha utilizing Myofiber technology means that it is more easily adaptable. And to make it all happen, the Clone Alpha uses a hydraulic pump similar to a human heart that circulates fluid through the robot's vascular system. Basically, this pump operates at 500 watts, providing the necessary power to drive the myofibers and enable Clone Alpha's dynamic movements. It also incorporates aquajet valve technology in its hydraulic system, which controls the complex network of valves within the robot and ensures precise control of the hydraulic fluid. But how exactly does Clone's choice of hydraulics for their robot's vascular system make it the better choice when compared to the traditional pneumatic models? Well, to start off, the pneumatics require a large and loud compressor. For context, Clone Robotics shared that when they initially used a 12-kilogram compressor in one of their earlier models with 8 muscles and a power of 1.2 kilowatts, it threw a thermal fuse and stopped working after just 1 hour of work. On the other hand, their much smaller 3-kilogram water pump consumes only 200 watts and can easily power 40 muscles 24/7. As a result, the hydraulic pumps are far more efficient, and because water is incompressible, it also produces far smoother motions without muscle vibrations that make pneumatic bots clunkier and louder. Clone Alpha's nervous system is just as impressive as its vascular system, with 70 inertial sensors and 320 pressure sensors for real-time feedback. This humanoid bot can respond instantly. These systems also communicate with a state-of-the-art NVIDIA's Jetson Thor GPU, which runs on Clone Robotics' latest CyberNet model. This advanced chip that acts similar to the human brain allows the robot to process visual feedback and exercise accurate proprioceptive abilities, which means it can tell exactly where its limbs are in space. Naturally, these features contribute to the AI's advanced fluid and human-like movements. In combination with cutting-edge biomimetic principles, the Clone Alpha is undoubtedly setting a new benchmark for humanoid robots in terms of strength, natural movement, and dexterity. It truly offers us a glimpse into a future where robots can effortlessly mimic biological beings and redefines what they can achieve. A microscopic view of Clone Alpha's nervous system shows how it is truly the perfect example of engineering meeting biology. CEO Dhanush Radhakrishnan pointed out that he and his co-founder Lukaj have been working on this project since 2014. The duo set out to make biomimetic super-intelligent androids and have been relentless in improving the biomechanics and scaling up for production. In an interview with Robotic Reports, Dhanush highlighted how creating such lifelike human muscles requires solving a lot of problems, like creating multiple functional joints or accounting for the different sizes of muscles and tendons in your hand. However, the founders were relentless in trying to create artificial muscles and were able to get around these challenges by utilizing hydraulic muscles with valves that use a pump and motor, like in a washing machine. Despite human hands being one of the most complex parts of our anatomy, they decided to start making prototypes, believing hacking it would be the most relevant way to solve their problems. Kind of like getting the hardest stuff out of the way first. And that was how they were able to create an actuator with a rubber tube surrounded by a fiber-braided sleeve. They also had to make custom bones, valves, muscles, and sensors from scratch so it could work. For context, when you want to move your hand, your brain sends signals to your muscles which cause the fibers to contract and relax, creating flexible and fluid movement. When these muscles cross a joint, they then can cause your fingers to form a pincer grip to pick up your pen or your shoulders to swing when you're playing baseball. This complex organic system is difficult to recreate in robots without muscles or nearly enough joints, which is what makes Clone Robotics' approach so genius. They recreated human-like movement by swapping muscles for fluid-filled cylinders. So whenever the robot receives the signal to move, pressurized fluid within these cylinders forces the pistons to extend or retract, creating a seamless motion that mimics a human hand. Combining these hydraulic systems with sensors also allows it to gauge how much pressure it exerts, enabling it to perform complex and delicate movements like humans. At the same time, hydraulic muscles can also exert high levels of force consistently, giving them an edge in lifting heavy loads compared to a human hand. They also aren't subject to the biological constraints that cause fatigue in our hands. Prior to their muscle-like actuators, you could only create human-like robotic movements through classical control with a human wearing a glove that allowed the robot to mimic such movement. But Clone Robotics' artificial muscles are fully autonomous, which has potential use cases in creating better human prosthetics with unmatched levels of mobility and dexterity from what we currently have. However, the company has confirmed that they are committed to making androids first, before exploring the possibilities of prosthetics. Still, that doesn't mean people living with disabilities would have to wait till we have perfect human-like robots. Once the first few samples become publicly available, other companies could reverse engineer the mechanics behind these Clone Robotics' lifelike hands and implement that knowledge in making groundbreaking prosthetics. Clone Robotics also shared videos of their synthetic hand that, composed of lifelike fingers and wrists, could form a fist and spread its fingers individually. Powered by hydraulic muscles, this robot flawlessly simulated the flexibility of real muscles, giving the eerie feeling of a human hand detached from its body. It also demonstrated remarkable strength, lifting an impressive 7-kilogram dumbbell. To double down on the achievement, earlier this year, the startup company shared a video on its official YouTube page of a biomimetic android robot with a human's shoulders, neck, and torso. With detailed human anatomical structures like the glenohumeral, scapulothoracic, acromyoclavicular, and sternoclavicular joints in place, the stark white robot recreated eerily similar human-like movements with artificial muscles. Under the torso demo, many viewers couldn't help but note how eerily similar the robot looked to something straight out of the American sci-fi series Westworld. On their official X page, Clone Robotics also announced that bimanual training was already in progress, and their hydraulic muscles be available for commercial purchase sooner than you think. Considering they also shared that they've taken pre-orders for the first 279 units, it's probably safe to say they're well advanced in their bimanual training. That means the robot can perform tasks with both hands and could effectively complete complex chores like laundry or washing the dishes without breaking your plates. So where slow, precise, and stiff movements would usually be a dead giveaway that you're dealing with a robot, Clone Robotics' hydraulic muscles are making it impossible to tell. Of course, Clone Robotics isn't isolated in using cutting-edge biomimetic technology to power their humanoid AI. The Bionic Lab at MIT is also using the same concept to build a dynamic acrobatic humanoid robot that can do parkour over challenging terrains. It wasn't too long ago that the mark of success for creating a bipedal robot was making one that could walk on a flat surface without falling over. These bots often featured the clunky, stiff movements most of us are familiar with from the Terminator movies, which often showed that these robots had limited flexibility compared to their human counterparts. However, thanks to Biomimetic Technology, which uses hydraulic pumps and water to replace traditional motors and actuators, the talented engineers at MIT have put together a humanoid robot capable of performing backflips off a 0.4-meter platform. Its leg design features new actuators with higher power and better torque density that makes the bot's heel-to-toe action smoother. However, while most of this is still only possible in simulation, the team is confident that their humanoid should be able to achieve these daring feats in real time. According to a member of the team, the acrobatic motions demonstrate the ability of our actuator-aware motion planner to generate feasible motion plans that push the boundaries of what our robot can do. However, biomimetic robots aren't limited in their ability to imitate humans. Festo, a German automation company, has made strides in creating bionic projects that mimic animals and insects. One of their most impressive inventions, the Smart Bird, is a bionic bird that can start, fly, and land autonomously. What's impressive about this bionic bird is that it doesn't have additional thrust engines but remains airborne using only the muscles in its wings. In a similar fashion, Festo has also been able to reproduce the unique way kangaroos move with a bionic kangaroo that hops like the real thing. This robotic marsupial consists of both sophisticated control technology and stable jump kinematics. In other words, it is able to store and retrieve energy efficiently with every jump. Other countries are also investing heavily in biomimetic technology. But unlike Festo's focus on whimsical animals like birds and kangaroos, China is putting this technology to use to build an army. Just off the coast of the Jisha Islands in the South China Sea, China successfully completed a test swim of a biomimetic robot that can flap its wings and slide underwater. They deployed a 460-kilo bionic soft robot prototype shaped like a manta ray that can dive up to 1,025 meters, showcasing amazing levels of adaptability and efficiency mirroring. By mirroring one of nature's most efficient swimmers, these sophisticated, lifelike robots can conduct underwater scientific investigations. But it also has military implications. Thanks to their autonomous nature, these biomimetic manta rays can act as weaponized submarines and make real-time decisions on the battlefield. In response to this growing military concern, the US is also developing similar technologies, with the Pentagon's defense agency testing their own submersibles called Manta Ray. But on a smaller scale, Clone Robotics first plans to deploy their impressive humanoid alphabots in the home. As a result, Clone Alpha comes preloaded with skills for basic movements like walking, grasping objects, and object recognition, allowing it to identify and interact with common household items. That also means, as a home assistant, the Clone Alpha can distinguish between your bag and a jacket when you tell it to fetch it for you. Thanks to its advanced telekinesis training, this AI bot is also capable of learning new skills from its owner, making it easily customizable for industries with complex procedures. It includes the medical field, where Clone's Alpha can help with invasive surgeries thanks to its precision, or on a manufacturing assembly line where they can handle delicate objects and perform intricate tasks. A fully functional Clone Alpha that could work side by side with humans on a manufacturing assembly line or assist healthcare workers in taking care of the elderly would drastically increase productivity in those sectors. The company's goal is to make low-cost musculoskeletal androids with human-level hands trained to perform all the common labor needed for daily life. So we might have to adapt to a world where these humanoid robots are a regular part of our lives. Right now, Clone Robotics is planning to scale up its manufacturing and enter commercial markets as soon as it creates a compact energy supply. For now, The focus is on delivering their first 279 units, which will act as prototypes, giving crucial feedback to the company before they scale up to mass production and start producing thousands of units. The company shared on their official X page that we started working on the brain only a few months ago and have not used the robot's visual and proprioceptive feedback yet. The legs will be ready soon and are based on the same principles as the rest of the body. So for now, we can't say for certain when they plan to officially launch the first fleet of clone alphas. So what do you think? Could this biomimetic humanoid robot be a stepping stone to something greater? Or the beginning of an AI takeover that spells disaster for humankind? Let me know what you think in the comments below.